Talking Comfort Live, a show that reminds us just how cool HVAC can be by discussing today's hot topics in home comfort. From learning to laughing and sharing personal experiences to challenging the leading industry narratives, our show goes deep inside the world of mini splits, heat pumps, and the inverter technology that brings efficient comfort to our products. And you can help us in our quest to make HVAC cool. We're looking for you to be a part of the show. If you have a question, whether it centers around application or installation, preventative maintenance, troubleshooting, a future technology, or anything we share on the show, please send it our way. We might take it live. Now grab a bucket and take a break. It's time for Talking Comfort Live.
Hey everyone, welcome to Talking Comfort Live. I'm James McIntyre, the Commercial Business Leader here at GREE. This is the 10th episode of this year. You can always check out our previous shows on our YouTube channel, GREE Comfort. If you haven't already, go ahead and follow GREE Comfort on YouTube and you get all the latest videos that we offer. You can also find these as well on the GREEcomfort.com website, where all of the help that you could ever want when it comes to GREE is available. First, we'd like to talk about why do we even do Talking Comfort. And the fact is, it's a great time to also introduce our other guests on here. We've all been in the same place that you guys have. We've been in your seat, we've been in your chair, we've been on your roofs and your attics and under houses and all that. So we've got Greg Bruntz. Hey Greg, what do you do at GREE?
Well, I mostly support the MultiPRO systems and the commercial VRF. But along with that, I do a lot of the training. I join with Daniel a lot of times in mini split training and FLEXX training and MultiPRO training and all the live broadcasts we do out of Atlanta. So kind of wear a lot of hats.
All right. Thanks, Greg. We also have Jesus Fraga. Jesus, you're a relatively new employee here, right? How long have you been working here now?
So I've been working here for a full 2 weeks.
2 weeks. All right.
A little bit longer than that, but yeah, about 2 weeks.
Yeah, but so you're just fresh off, you're fresh out of being a contractor, right?
Fresh off the road.
That, right? Yeah.
Yes, sir.
Yeah, you were a business owner and everything, right? So you were doing this up until just a couple weeks ago. Yeah.
Yes.
So are you glad to be out of attics now?
Oh yeah. Too many times I've been up in the attic, 100, 120 degrees, just being like, man, this sucks. But
Right.
it's rewarding though.
Right. So that's one reason why we like to do this, is that we can share some of the experiences that we have to let you know that we're not just some random folks that decided to try to support air conditioners and heat pumps. But it's also a place that you can provide your feedback. You can share your questions and comments, and just at any time. There's a question mark icon to the right of our screen, and you can submit your questions or your comments at any point, and then we will check in on those throughout the rest of the show, and answer those questions at various points during the show. So if you've got questions and you've never been able to get answers to those, feel free to go ahead and ask those. All right, on today's agenda, we're going to be covering preventative maintenance, which I think is a pretty good time of year to do it, but we're going to go over that. We're going to cover subcooling and heat pumps. And then we're going to go to our stay heated or chill out segment with Jesus. And so during that, we're going to need help from the audience or from you to decide if he has the right to stay heated or if he needs to chill out. So if it's something that he should be kind of angry about, you can vote stay heated. And if it's something that he needs to just calm down about, you can vote that he needs to chill out. All right. Always like to have a little bit of fun with stuff like that. And then we're going to respond to a few comments that we receive on our YouTube channel. We don't respond to every comment on our YouTube channel. You've seen comments on YouTube, and they get pretty interesting sometimes.
They get very interesting.
Yeah, they do get very interesting. I've made a couple of interesting comments myself. But again, we encourage you to send your questions and thoughts anytime, because we'll be checking on those throughout the show. So let's go ahead and start talking comfort. And we're going to begin by going over our Misnometer. So Misnometer number 1, what does our Misnometer say? It says fall and spring are the best time to perform preventative maintenance. All right. So what do you think? Is fall
Myself,
and spring the absolute best time to perform preventative maintenance?
myself, I believe that for a long time that was the proper time to do it, because I was believing it because that's what the company was telling me. Because I was able to, stay working in shoulder times when you didn't have a lot of no cooling or a lot of no heats and stuff like that. So, but then I went to work for another company, and we were so busy year round, and we had a lot of maintenance contracts. So a lot of times you weren't doing your maintenance on systems until June, July, when it's very, very hot or when it's really cold. So my opinion of that changed because now I was actually going out and doing preventative maintenance on equipment where I could see it actually loaded up. So there's good times, it doesn't hurt to do it in the spring or fall, but it definitely doesn't hurt to see that system when it's under normal load conditions.
Right.
Because what you see under low load conditions, you may not necessarily see under normal conditions.
Right. I would say particularly with inverter driven systems. We see that a lot, that you can get away with something like a low charge for a big chunk of the year, depending on where you live too. If it's relatively mild climate, you can get away with it for a long time with a low charge. Customer has no idea, that it's low. They have no idea that it's leaking, that kind of thing, until it does break and decides to become cold or decides to become hot. So that may be something that you don't pick up on during preventive maintenance.
Or it may just be until it's under high load, then the machines, which GREE does an exceptional job of with their equipment, is protecting the equipment from damage, but also keeping it running, even though we're not being able to get full capacity out of it. So the consumer or the tenant in that building or whatever it may not actually be getting the comfort level that they want, but the machine is not getting damaged either. And that's a prime example of one that you may not see if you were out there in the spring or under low load conditions.
Right. But,
So
so I can definitely see that. Zeus, what do you think about that?
Yeah, I kind of agree with Greg there, saying, it's traditionally people are said to do it like during the off season or shoulder seasons. Uh, but I mean, honestly, you know, to really get that full, because you have load in the building, so you're gonna want to see that system run, at full capacity. And if you don't have that, like on the shoulder seasons where it's a little bit colder, and you're trying to check like the cooling cycle, well, I mean, you're gonna shut off pretty fast. So that's where you can run into issues there. And if you don't have the instruments to be able to, test the heat pump mode in heating, well, you're kind of, dead in the water, really checking the full system thoroughly.
So, I mean, but in the interest of the contractors that are on here, though, I mean, we got to be fair, right? Yes, I think it's good to be able to see the equipment in loaded conditions, and that's what the consumers need to understand. That it's not going to hurt them either way to have it done in the spring or the fall, or even in the prime season when it's actually under load. Because let's be real, the contractors are going to go out there and do these preventive maintenance checks when the time allows. In other words, you're going to take care of people that have nothing or a system down first before you're going to be running PMs, because PMs really don't make a contractor a bunch of money or anything like that. They make their money off of doing service work and repairs or replacements. So they've got to be able to factor that into their schedules and keep their guys working full time. And that's where preventive maintenance comes into play, because it gives them, when that technician doesn't have another job, might be like a 4-hour job, and there's not enough hours left in the day to do that, but he can go do this maintenance at the end of the day or the beginning of the day, just to start the day. Okay, you got a 6-hour job planned, you go do that maintenance in the morning first. So, and I guess what I'm trying to encourage is contractors to do a better explanation to their consumer as to when they're getting their preventative maintenance done and why. So the consumer doesn't think, it's got to be in the spring, or it's got to be in the fall, or it's got to be in the middle of summer, it's got to be in the middle of the winter. So, because not only that, they got to work around holidays. Nobody wants somebody coming out and doing preventive maintenance on their HVAC system on Christmas Eve. I mean, some will, but a lot of people, they're trying to cook and plan for their family coming in.
Trying to get you in there and out of there as quickly as possible. Yeah, well, I mean, I think that brings up a couple points. I mean, I think one is, one step in preventive maintenance is just checking the common maintenance items like coil cleanliness or blower wheels, that kind of thing, right?
Electrical connections, all that kind of stuff. Yes.
I mean, even flare connections, if that's, something that you would be looking into. And if you're out there for one reason, maybe that's something that you just go ahead and add in, that kind of thing. But then on the other hand, you're also talking about like preventive maintenance contracts. And and I think that's part of the reason why they have been scheduled in the slower seasons, which, doesn't necessarily occur in spring and fall, like as far as months go. Absolutely just depends on where you live, what kind of climate you have. Some places don't really have shoulder seasons.
Right.
I kind of live in one. I wouldn't really consider this to be a shoulder season right now. It could be 90.
Not everybody lives in an easy
70,
easy bake oven.
Yeah, that's true. But so those I know when I moved here, a lot of the PMs were done in the dead of winter. On the commercial jobs, they might send 5, 6, 8 people out there,
Yep.
all at once to go do those, because it's kind of used to kind of keep some of that work going. So I totally understand that. But I think like if you have a pretty good idea when you're going to start getting these no cools or no heats, if you're able to go out and perform some preventive maintenance on it. I mean, this applies to wall mount mini split just as well as it does to a whole house unit. There's definitely preventive maintenance that needs to occur. I know that we've talked about that in more than one occasion on Talk Cup for Live. Is tech support gets pictures of the units. Like, hey, it's not cooling. I don't know what's wrong with it. We pulled the charge, we weighed it back in, all the rest of that stuff. You get a picture, and then it's it's caked up. It's got a bunch of junk on it, and all the rest of that. It's like, okay, you still need airflow. Still an air conditioner.
Right.
It might be inverter driven. It might have sensors and stuff in it, but it's still an air conditioner. It may not be freezing up into a solid block of ice, right? You may not get high amp draw because it's returning liquid to the compressor because it's not doing that. It's going to protect itself and try not to do that. So I mean, dirty coil doesn't always equal frozen coil.
Exactly.
Airflow doesn't always end up being a frozen coil either. Especially with the with inverter driven systems.
Well, we definitely have air codes for freeze protection.
We do.
We also have air codes for high discharge temperature, which would be same as high superheat, meaning we're not getting refrigerant flow back. Could be from undercharge, could be from restriction, could be from other things. But like we just talked about, there is safety factors in there.
Mm-hmm.
But the other thing I'll share is when I did PMs, if I felt like a system, in the shoulder season, it wasn't really giving me the answers I was looking for,
right?
Or if I thought there might be an issue with it, then I would always write those up as we need a return visit when it's warm outside, right? So,
right.
Or cold outside or whatever it may be, so I could see it under loaded condition. So, and then what they would typically do, the office then would typically schedule a date, a month and a half out or whatever, when they knew it was going to be warm. And then that way that customer was already on the books for a recheck,
Right. And I know too that, it can be challenging selling like a preventive maintenance contract to a customer. It's like an insurance policy. Even though they might have insurance policies, they may not want to buy one for a preventive maintenance. I mean, it's not really insurance, right. But you get what I'm saying. Like, you might be able to identify problems with it before problems actually occur. Not everybody's always a long-term thinker. Like maybe a lot of people are looking at it from a short-term. Maybe it can also be that they just maybe they can't afford to think long-term or something like that. There's always a challenge there. But No, I think that's some good points. I think a lot of it is built around just the company and the business that's occurring at different points of the year. But if you got any thoughts on that, if you'd like to add something to that, please feel free to use the question mark icon to the right of the screen and give us some feedback on that. Maybe there's something that we missed or something that you feel like that maybe you're heated about and you want to, go out there and let us know too. And maybe it'll be, maybe it'll get us riled up. You never know.
Well, I mean, I think we failed to mention the reason why we brought that up anyway is because of the fact that we feel like, consumers, are not understanding the importance of getting their equipment, having regular maintenance checks done on them. So,
Yeah.
and I think that's another thing that, we want to try to get homeowners and stuff to understand. I mean, you change the oil on your car, you have regular maintenance done to your car. Why aren't you doing regular maintenance to your HVAC system? You should be.
Right. Well, some of us are better at cars too than others, right?
True.
um,
Out of sight, out of mind. That's the thing,
right.
All they
Yeah.
do is turn it on and they don't think about it because it's conditioning in their house.
Yeah.
Think
And
about
I do
the fact
think,
that-
I think preventive maintenance seems to be one of those things that's lost, going from traditional systems to like mini splits. I just think like one of those things that just gets left behind. I mean, it's no different than, something that we talk about fairly often is, showing up to the job site. It's a mini split. All of a sudden, it's not saying everybody does this, but we've all done this at one point or another. You look at the unit and you immediately start thinking, oh, well, this is different. So that, maybe it's this is the problem. The other thing's different. So maybe this is the problem. And not really thinking about it as like an air conditioner. Like you still have all of this knowledge that you're bringing to it, all this experience that you're bringing to it, whether that's 5 years or 40 years, you're still bringing that everything with you. 90% of the problems are better are typical HVAC related problems, have nothing to do with an inverter or a thermistor or a digital controller of some kind. It's got nothing to do with that at all. It's airflow, it's refrigerant, it's
Well, when I was in trade school, one
cleanliness.
of the first things they taught us was that our biggest enemy in HVAC is dirt.
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 Yeah.
From the filters getting dirty, the condensers getting dirty, whether it's a reach-in refrigerator or it's a HVAC system cooling your house. Dirt is the biggest enemy in this field, and lack of maintenance is what causes a lot of the breakdown.
Mm.
So,
James, that brings up a good point on the maintenance side of it. Like just pretty much breaking it down from a troubleshooting standpoint, just the basic stuff that you can cover in preventive maintenance. So like to avoid like nuisance calls, dirty blower, dirty condenser, just go ahead and do your preventive maintenance to the full of your ability and should be good to go, unless until a actual problem comes up, you can get a lot of it during the preventive maintenance.
Yep.
Right. Right. Okay, well, let's check out Misnometer number 2. And again, if you had any thoughts on that, any comments on that, question mark to the right of the screen. Misnometer number 2, what do we have here? It says subcooling is not important to heat pump performance. Well, I feel like you guys might have some thoughts on that. I guess this is in reference to folks who are really just paying attention to superheat, or
well,
what do you think?
whether it's an inverter-driven system or a standard system, having a solid column of liquid behind that metering device so that we can feed the evaporator coil is just as important on any system, any HVAC system. Whether it's inverter driven or not, the basics behind air conditioning haven't changed. And the basics have always been, your evaporator temperature should be around a 40-degree coil. Yeah, they'll run 32. Yeah, they'll run 50. But in order for that evaporator to have the proper amount of refrigerant in it, it has to have that solid column of liquid behind that metering device. And that's where subcooling comes into play, measuring subcooling. When it comes to inverter-driven units, it's a little different compared to single-speed systems or two-stage systems where you can lock that speed in and have a known subcooling. When it comes to inverter units, we've got units that might be running at 30 hertz, it might be running at 50 hertz, it might be running at 80 hertz. So there's really no way for the manufacturers to give us specified subcooling numbers to be able to charge like that. So you're better off to. That's why we constantly say on inverter driven systems, if there's a charge problem, we know the unit was low on charge, we know the unit had a leak in it, had to be fixed, whatever the case may be, the final recharge of that unit needs to be weighed in because they can't give us those critical numbers for field type of charging, put it that way. Yes, they know that stuff in their plants and their factories, all their engineering data and everything they run to know how much charge has to be run into them, but it gets way more involved than what we can do in the field as far as adding charge. Now, I'm not going to say, and I've told guys this before, even on I'm working on a mini split on the phone or working on even a GMB unit, or no matter what it may be, I'll tell them, look, man, I know you're busy. So if you know it's low and you can charge it to where you get a decent temperature differential across the indoor unit, you're running a decent suction pressure compared to when you first got on, it was running 20-degree evaporator coil. You know it's low and our discharge temperature is reading high. Then, yeah, add some charge to it, get them going until you got the time to come back and do a full repair. So you can't always get away with doing that, but it's definitely worth that shot. I mean, if you know it's low and you don't know exactly how much, slowly add some charge and see if we can't get those numbers looking a lot better and get the temperature splits across the indoor units where we need them to be without getting too much refrigerant in it to work, because again, the GREE systems do a great job of protecting themselves. So if it's running a little low on charge, that's not going to throw it out on an air coat. It's going to limp along and run still. So add some charge into it to where we get a little bit out of that limp mode and more into a decent temperature differential across the indoor unit. And then come back when you got that 4 hours or whatever you need to actually go in there, find the leak, repair the leak, and do a triple evacuation and weigh the charge back in. That's just my suggestion. And I've had guys do it on the mini splits many a times, and they'll typically charge them until they get like a 20-25 degree split across the indoor unit, and then they come back when they got more time because that day they've got 4 or 5 service calls after that call. There's nothing wrong with that. And that's not what we're trying to tell guys. They're like, what do you mean I have to weigh the charge in? What we're telling you is you have to weigh the charge in if you want it done right. Doesn't mean you have to do it right that second. You may need to just get it to limp along better until you have the time to come back and actually make the full repair.
Right. Well, I do get asked sometimes, like the MultiPRO systems can do 295 feet from the outdoor unit to the indoor unit. And they're like, how? A big reason for that is the fact that we do have a subcooler in the outdoor unit that can maintain that subcooling. So like we might need quite a bit of subcooling to be able to do that without absorbing a bunch of heat on the way in. Or if we've got, a multi-zone style system, like a multi-zone MultiPRO system, or we've got multiple indoor units, we're going to have a significant amount of subcooling as we pull liquid off of that liquid line, going to one unit and going to the next unit and going to the next unit. Well, you're going to have a fair amount of subcooling to be able to do that. You want a solid column of liquid. If you do not have a full column of liquid, you're going to have bubbles. And if you got bubbles, you got poor cooling performance, right? So, charging these units just based on subcooling, I mean, yeah, you can get there. You can get to something that looks more normal that day, that kind of thing. But at the same time, I mean, that's why, people will often ask, like, if you could just lock it in, to a maximum level, that kind of thing. I'll be honest with you, if you have an inverter driven system and they give you a chart and it says something like 9 to 19 on the subcooling chart, something like that, it's typically not from the factory. It's typically from somebody else, somebody like me, or Greg, or Jesus at a different company that just says, this is what we've seen, a certain range. And that's something, if you thought it was low in refrigerant and you're adding refrigerant, it does get you closer to what it should be by adding refrigerant, right? But it's not, tricking it into running 100%. There's not really a way to do that because, built-in protections are going to come into play. They're absolutely going to do that. Standard system, if you ran it like that and you just continue to run it like that and it ignored any kind of input, like you just put jumpers on Y, right? and you're just cooling, yeah, I mean, if you dropped airflow out, is it going to freeze up? Or like if it just continues to get cold in the space, is it going to freeze up? Are you going to return liquid to your compressor? Are there any protections to prevent that? No. So you can't do that with an inverter driven system typically. You can go to max, you can try to get it to max, but it's going to provide you the maximum amount of capacity that is available at those temperatures. You know, like I only got to run so fast on an 80-degree day to give you 3 tons. And, you know, when it's 100 degrees outside, I got to run a little bit faster to give you 3 tons. You know, if I locked it in, I'm giving you significantly more capacity. You're running it outside of norms at that point, you know?
Well, I mean, and just to mention, like you said, a lot of these units, like the GMB units, the MultiPRO units, have subcoolers in them. So if the system's low on charge, it's already trying to save itself by subcooling that refrigerant more using the subcooler. so we're going to be, you know, utilizing the subcooler more if we're low on charge and less if it's got the right charge, right? So how do you figure out what that charge difference is as to when, you know, that's all proprietary information that the manufacturers are not going to give you as to exactly when and how they calculate when the subcooler is going to be, you know, subcooling more refrigerant versus less refrigerant. It's a lot of math and a lot of programming involved in the whole and all the thermistors and stuff that it's looking at. So, you know, to get the efficiencies that these machines give us, which is exceptional, and the performance that they give us, you know, yes, unfortunately, it's going to be different than a unitary product where you can lock the speed and say, okay, here's my subcooling is where it's supposed to be, my superheat's where it's supposed to be, my airflow is where it's supposed to be, my temperature drop's supposed to be, that unit's charged.
Right.
But, you know, so I guess I'm just trying to make sure everybody understands the point that if you're getting into the higher efficiency units and the higher performance of those units using an inverter driven unit, it's going to have some of its downfalls too, in that when you go to add charge, yes, it's not going to be a simple.
Yeah, I mean, you can take a
starts
basic
and
single
take
zone
in.
mini split, for example, and you're going to have, you know, a dozen variables that are being monitored at all times. You know,
Right.
outside temperature, inside temperature, liquid pipes, suction pipes, speed of the compressor, speed of the fan motors, you know, both inside
Except for
and
the
out.
EV,
Yeah, EV
all of that.
positions, all of those things all at once. And I mean, the way I learned it was I have one clamp on thermometer and I know the saturation temp.
Yeah, and how many thermistors you have on that same machine? So they got a lot more
7.
thermometers on there than we do.
Yeah, right. So it's looking at the same things that you would look at to determine whether or not it, you know, it can run properly. And that's the reason why we end up with the error codes and stuff like that. But I mean, if you think that you've got a reduction in capacity and you've eliminated airflow both indoor and out, right? If you eliminated airflow, I mean, the other thought process, of course, is if you thought you had a leak, you know, there is a repair that should be done at that point, right? We
Right.
know it's leaking. There's, you know, there's regulations behind all that.
Well, in our tech department, and myself too, will say repeatedly, when you take it out, weigh it out. When you recover the refrigerant, weigh that tank before and after you're done recovering that refrigerant. That way, you know exactly how much refrigerant you pulled out of that machine. And if you know the calculation and you get the total charge amount that's supposed to be in there and you pull out significantly less, then you absolutely know there's definitely a leak in the system somewhere. And we got to find that, get that corrected before we weigh that charge back in.
Right. I mean, well, you know, you and I had a commercial job site not too long ago. You know, they first went out in the spring, added some refrigerant. You know, they go back out a couple weeks later, they add some more refrigerant, and you know, so on and so forth. And then when they finally, you know, because I mean, it's heating up, right? It's heating up because it's spring. It's heating up, so it, you know, it works okay for a week or two, and then it, you know, it heats up a bit more. Then it's not working that great, so they add some more, and they add some more, and they add some more. And they ended up, you know, just being grossly overcharged. You know, there's other reasons why, you know, these systems may not be performing properly. You know, so when somebody just says, I checked the charge, it's like, okay, what did you do? Even with the service tools that we have, it's still a lot of data all at once that you're trying to figure out. And, you know, it can be be very difficult to figure that out. But I mean, you can know without a doubt. If you were looking at discharge temperature, and when that unit first cranks up, it ramps up. That discharge temperature ramps up with it. It gets real hot, gets up to like 200 degrees, and then it slows back down and kind of chills there for a while. You don't have the volume of refrigerant that you need. Doesn't need necessarily. It could be other things why you don't have the volume. You could have a restriction. The EV could be stuck. It could be a lot of things. But that's usually a pretty clear indication. But
so I can give an example
yeah.
on a scenario with a multi-zone mini split. This was in another life for me. I wasn't working where I am today, but I was also in this support role of technical support on this for mini split, and it wasn't a GREE unit. It was a completely different manufacturer, but it's kind of all the same thing, right? The contractor called me and told me the system wasn't keeping up, wasn't going properly, no error codes. I says, okay. On that particular machine, you can go out of the outdoor unit, you can toggle through all the thermistor reading. So I emailed him exactly how to get into that and how to record all that data. Now, unfortunately, it was in Celsius. On that machine, there was no way to change it to Fahrenheit. And I said, so now I want you to go back on the job. This job had 4 indoor units. And I said, I want you to let that thing run with 1 indoor unit for about 5 minutes and record the discharge temperature and all the other temperatures. And then I want you to let it run for another 5 minutes with 2 of them running. Then 3 of them running. Then all 4 of them running. And the guy calls me back the next day and goes, I got your data. I go, my data? That's your data. Did you try to digest it at all? He goes, no, I just gathered the data. I said, okay. Did you convert it to Fahrenheit so we can understand it better? No, I didn't do that either. Okay, send it to me and I'll do it. So I did it. I converted all to Fahrenheit. I called him back. I emailed it to him. I'm like, now open this up and look at it. I said, tell me what's wrong with that unit. He goes, I have no idea. I said, well, if you look at it when 1 unit's running, the discharge temperature was not that bad. And as the second one came on, the discharge temperature went up more. And then as the third one came on, the discharge temperature went up even more. And then when the fourth one come up, it was really getting into some high discharge temperatures. I says, what do you think that means? He goes, I don't know. I said, it's low on gas, man. You got a leak. And he goes, oh, that does kind of make sense. So then I seen him about a month later at a training class I was doing. I said, so whatever happened with it? He goes, you were right. It had a leak in it. So what I'm saying is, and I'm not trying to be, know-it-all or anything like that, but that is there for a reason. If you're running 155, 165, 175 discharge temperature, that's not that bad. You start seeing discharge temperatures off your compressor at over 200 degrees, you're not getting enough refrigerant back to that compressor. You don't need to know specific numbers. You just need to know what's definitely not good. And over 200 degrees, actually even over 190 is entirely too hot.
Right.
So, and that doesn't matter if it is a mini split or if it's unitary product, a single stage system. Discharge temperature is discharge temperature. The warmer the gas goes in, the warmer the gas comes out. Because all the compressor does is compress it.
Right. All right. Any more thoughts on that?
Yeah, I was just gonna add about the subcooling and it being important. I mean, let's not forget the reason why we turn to inverter systems is to get that efficiency that that is promoted, and it's there, but we do have to have those parameters correct, and that means having correct refrigerant charges, having correct line sets, having correct pretty much applications versus indoor and outdoor. So yeah, subcooling absolutely critical to get those numbers that we see and that we get excited for when we see them.
Yeah,
So
I'm
it's
so
just
glad
to add that.
you brought that up, Jesus, because I didn't even bring up the fact about refrigerant line sizing, because we repeatedly get asked the question, hey, we already put all this piping in. It's not the right size. It's supposed to be this. Is that okay? No, it's not okay. You got to go by the manufacturer specifications for all these reasons that we're talking about as far as getting the charge right and everything else. And then also with mini splits or MultiPRO, on indoor units. What you got to remember is that suction gas line in cooling is, if it's the wrong size, let's say it's small, maybe it's supposed to be 5/8 and you only got 1/2 inch, or maybe it's supposed to be 1/2 inch and you only got 3/8, whatever. Okay. Remember, that is your suction line in cooling. In cooling, that's probably not going to be a problem. But when you go into heating mode, that same pipe just became your discharge pipe and it's too small. You can't have too small of a discharge pipe in heating mode. That's where it's going to be a problem. And we've seen that many a times on the multi-zones where they use the wrong size line set. And they said, well, run fine all summer. Well, yeah, it will. Then when you get into wintertime and that discharge line is too small, that's a problem. So,
Right.
I like to try to give examples so everybody understands more where we're coming from.
Sure. No, that's great. I mean,
Like we could talk about.
yeah, I
We
mean,
have
it
some
serves as a
time.
restriction. I mean, that would be like mismatching a coil. You know,
Right.
like your indoor coil be too small or whatever, or be like a fancy low volume coil, for example. You know, you might end up with problems in the winter. You know, that kind of thing. So we're going to take a look at some of the questions that have come in. All right. So I'm going to go ahead and remind you one more time, because we love the questions. Please submit some questions if you got it, or if you think somebody else might want to hear, even though you have the answer, somebody else might benefit from it, from what you're asking. Please feel free to do so with the question mark icon at the right of your screen. All right, so let's take a look. Okay, we've got a question about R32. And of course we do, right? That seems to be the most popular topic right now. Don't blame me for that. Is basically what the plan is with R32. The plan for our R32 transition is that we will continue to sell R410A as those units or those models become unavailable. We will transition those models over to R32. So if we, just for an example, Greg likes examples. If we were to sell all of the 18,000 BTU units, for example, you know, available in R410A, then we would just transition those over to R32. So that's how that works. So the importation date, you know, for us, because we know everything that we have is imported. The importation date limit set by our United States government has been December 31st of this year. So everything that we're going to have in R410A and 5 ton and down is going to land before the end of the year. So we'll have a fair amount. We are going to be able to deliver R410A equipment for quite some time, it looks like, which should be a boon for most of you. And then, like I said, we'll transition over to R32 as they become necessary or as they become available. So.
And the other part of that question is we absolutely will be supporting that equipment for years to come. And 410A is not going to go away overnight. The refrigerant will be readily available for repairs, whatever the case may be. But yes, no, the warranty will still stand, and we will stand behind those units. And if you need parts or compressor or whatever the part may be, we intend to fully support those units. And I also, with R32, I've already seen some chatter online about, you know, I'm not gonna, if the equipment's being phased out, I don't want no part of that. I want the new equipment. You know, I don't feel like any consumer out there should be worried about, you know, having to have the new R32 equipment, or, you know, not, or wanting the 410A equipment over the new R32. The refrigerant's going to be around for years to come to be able to service and maintain these units. I don't think that it should really be a concern either way. The only concern that I think might be a benefit to the consumer would be that I think you're going to see, and it's not going to be drastic increases in price, but the price will go up with our 32 equipment.
Right.
So if you're looking to have to replace the system, I would suggest that they look at the 410A systems while they're still available, because they'll be able to do it at a cheaper price than waiting for R32 equipment.
Right. And like you said, I mean, it's not, it's a mostly negligible price difference from what we've seen so far. But you know, I have gotten a lot of feedback for the competitive refrigerant, and it seems to be substantially higher. So, you know, that's just something to take into account. We're going with R32. We think you should too. That almost rhymes, but you know, that's what we're going with. But yeah, I mean, due to its availability and all that, and you know, you know, maybe it's a dead horse, maybe we're beating it. I don't know, but you know, we've talked about it a lot on Talking Comfort Live this year. But I mean, it's the most significant change to HVAC since 410A, right?
What are you trying to say, James? We need a new slogan. R32 is good for you.
Yeah, good for me, good for
Like
you.
that rhyming
R32,
stuff.
yeah, something like that, right? Yeah, yeah. Um, so we do have a question about someone interested in becoming a distributor outside of the continental United States. So if you would, Mr. Bastian, you can go ahead and enter your email, like, you know, as the question. You know, hit the right, you know, the question mark icon on the right of your screen. You can send us your email. We'll put you in touch with some folks that'll be able to help you out on that outside of the United States. If you're inside the United States, please purchase from us. Uh, we got another question. I don't know if this is necessarily related to like our controls, but we do have some newer controls that have these. It's unoccupied versus occupied operation modes. It says that their customer has an inverter-driven system that is using unoccupied or occupied operating modes, and want to know what the difference is between those and to get that to working properly. So, you know, with a function that you might be familiar with is like our sleep function. It's effectively also operating as an unoccupied mode. What you effectively get is just a setback is what you get. So the you know, in cooling, if you have it set for 72 while it's occupied, unoccupied is going to set it for 78. It's an attempt to save some money by not having to have it run as often. The savings that you get running unoccupied versus occupied with an inverter driven system aren't as significant as non-inverter driven systems. Most of the time, we would recommend that you set it and forget it, like the Roncomatic rotisserie grill. I don't know if you remember that or not, but but set it and forget it. Seems to work, you know, great because it can slow down. Traditional systems cannot do that. All you're really doing is controlling the amount of time that it's on. So wouldn't be using that too often, but it really does just serve as a setback normally, right? Would you like to add something to that?
Yeah, I've always said when you're doing any kind of a setback or anything like that, when it comes to cooling mode, remember you're moving heat. You're not making cold air. You're taking heat out of one space and moving it to another space, which takes a lot of energy to do that. So if you're putting high demands on the equipment, in other words, let me give an example. Let's say you normally keep your house at 72 degrees in cooling mode, and you're going to be going unoccupied, or you're putting away or whatever, and you're setting that thing to 80, you're giving that thing an 8-degree demand when you get back. So now if it's an inverter driven system, even if it is a unitary product that's a first stage or second stage, it is absolutely going to be running at full speed to catch back up. And here, what ends up happening then is you're going to end up having a really long run time for it to catch back up. And you're going to be doing it at a high hertz. And when it comes into inverter driven equipment, your efficiency comes from maintain temperature at a lower hertz, lower compressor run speed. So when you're constantly giving them high demands, you're forcing that compressor to run those high hertz modes. It's not going to hurt the compressor none. It's not going to hurt the machine none. It's just going to raise your electric bill.
Right. So back to the R32 question. Just want to remind everyone that we do have a video on our YouTube channel with our product director, Justin Silsbury, covering the R32 rollout. So if you wanted some more details on that, or to be able to go back and reference it, it is on our channel. And you can search the channel as well. So, you know, if you just typed in R32, for example, that's going to come up. So if you wanted some more information on that, it's there, ready to go. And maybe a little bit better communicated than what I did. this is what you get without a script, right? Right. So,
I don't know, script more prepared for the question, which we don't deal with that question a lot.
not too much. Okay, let's see. We do have another question. Is the interface of MultiPRO used on the FLEXX? Oh, I believe that would be referencing the portable commissioning tool or one of our commissioning tools. Do we have a commissioning tool for FLEXX?
We do not currently have a portable commissioning tool for the FLEXX unit.
Okay, or a service checker, service data, whatever.
There was talk about GREE building one, but I don't think they ever really agreed that they were going to build one.
Right.
So I think they will have one. If I understand, if I remember correctly, with the R32 version of the FLEXX, they are going to have some serviceability factors into that unit, but it won't apply to the 410.
Right, I got you. Okay. Yeah, so they do updates on those every so often on our our, what we call a portable commissioning tool, but if you have another term for it, maybe service checker or whatever. It's something that's used with our MultiPRO systems because that data is available. But that doesn't currently work with the FLEXX. But yeah, I was under the same impression for the R32s that we'll have a more of a universal data checker.
So right now, currently, what they offer is a single zone mini split service tool, a multi-zone mini split service tool, and then the MultiPRO service tool. That's what we have.
Gotcha. Okay. And then we have a question about GREE Select Dealer. And where do we go to find the training, the 4 hours training that's required to maintain your GREE Select Dealer status? I believe that is under the, just a second. I'll go look for it right now.
It's under, if you go under GREEcomfort.com and you go under the contractor tab, there's a training tab there. And if you scroll down, it gives our whole training calendar. And we have live broadcasts and Tech 90s that you can attend, and those would qualify.
Okay, I got you.
And I believe they can also do GREE University.
Right, I believe so as well. Give me just a second here, and maybe I'll just get logged in, and I can tell you exactly. I believe it is something that you have to log into. There is also a verification code, so give me just a moment here. People that know me, if they could refrain from texting me during the middle of a broadcast, that would be great. Get my verification code.
So, James,
yep,
Tatiana could chime in on that and give us.
Right. Yeah. Yep. Yeah, we might have to get back to you on that. I know that we've got videos on that as well. Let's see. Oh yeah, okay. She says that they give the flexibility to be able to do it at their own pace. But if you have questions on that, reach out to tforce@twclimate.com. So that's T as in Tatiana, and then FORCE at twclimate.com. And you can ask your questions for GREE University or anything that you might have questions on related to the GREE Select Dealer program. Okay.
Excellent.
All right. Let me get back to these questions here. All right. We do have some feedback on the webinar from September 5th. Is not available to review. It's not opening. I believe that would be what, through the YouTube channel?
Let me look at which one he's talking about real quick. Hang on.
Okay. Sounds good.
Give me just a
See
second.
if we got any other things here. All right. I tell you what, how about in the meantime, while we go ahead and find that, let's go ahead and run a video for, let's see here.
I can answer that
Yeah,
real
All
quick.
right.
So
Sounds good.
that September 5th broadcast, that was a live broadcast. Live broadcasts don't get put onto YouTube. They don't get added to the channel. Some of those broadcasts, we will take some information from it and we will repost it and present it under a Tech 90. And then it will get uploaded to YouTube.
I gotcha. Okay.
So, but since there's interest in that, and I've heard it from more than one person, I'll see what we can do about getting some edited video on that to be able to rebroadcast part of that show and put it on YouTube.
Okay. So we'll get it put on YouTube then. Is that what we're talking about?
I'll work on that. Yes.
Okay. Got it. All
In
right.
other words, we want to edit it down and get rid of some of the lag time that you get in a live broadcast and stuff like that.
Right.
So we only have the video content that's pertinent to what people are looking for.
Right.
So that they're not having to watch a real long video that they don't want to watch. So
sure. Well, I mean,
will-
I hope it's not evident to the viewers, but we are heating and air people. We are not professional broadcasters. So there is a lot of time delay and and stuff like that, sneezes, coughs.
So it was recorded, so I'll get the video sent over to me and we can edit it, get it edited down and get it posted.
Got it. Okay. All right, that's what we got for questions so far. Now we've got an audience vote. So as we cover this next topic, you can vote for Jesus to either stay heated or chill out. That you can find that in the same place where you would be posting a question with the question mark icon to the right of your screen. So, okay, Jesus, let's hear about your problem and why is it you're heated about being unprepared for the job on the date of installation?
I have a unique perspective being the technician and the contractor. So, I mean, you want efficiency at everything, not only just the units that we're putting in. So that includes the workmanship that you're putting out. So being prepared is absolutely crucial to pretty much being done on time, coming in budget, and pretty much just having a smooth install or service call, depending on what it is that you're doing that day. So if you could plan ahead, for the next day's work, that's great for business standpoint. So that's why I think that, staying prepared is absolutely crucial. And I preach that every single time.
Right. Okay. Yeah.
I agree with that. That's a good thing to stay heated about. In that, so I know a lot of people still don't use the internet as much as we do because we have to support equipment. We're always on our own website and everything else. But just simple things you can do to make sure you're prepared for the job. You can get on the internet real quick, make sure the model numbers of the equipment that you have, your outdoor unit, your indoor units, is a proper matchup. Those kind of things, make sure if you've never installed one before, especially, make sure you understand, pull up the installation instructions real quick on the website and look through. Do I have the right wire? Do I have the right, communication wire? We preach that with the MultiPRO versus mini split, because mini split uses a 4-wire conductor and MultiPRO uses a separate power source to each indoor unit, and we use an 18-2 communication wire. That's the things that I'm talking about. Whatever product you're going to be putting in, especially if you've never installed one, do a little bit more homework and making sure that you have the right stuff. As much as we all want to rely on that counter guy, that has sold you all the right stuff. Let's keep in mind a lot of the counter guys, and I'm not calling out any one specific distributor anywhere in this country, but a lot of those guys are not, they're not you. They're not the installing guy. They're not the one that's going out there and installing the job and knows enough about that equipment to make sure you're getting all the right materials. I would take my time myself and spend that 15 minutes, half hour, whatever, and make sure I have all the appropriate materials to be able to go do that job.
Yeah, that's a good point, Greg. Especially what you said about, we are the people or I was the person installing, but for the techs out there and the contractors out there doing this work, the stuff that you get, even brand new, you just want to verify just to make sure that those are the correct part numbers, those are the correct model and serial numbers. And just because you don't want to show up at a building or a house and, it'd be, oh man, what's wrong? And I got to go back to the supply house and there goes another hour going back and forth just to get the right part when you could have done it in the parking lot or at the counter with the guy that's checking you out.
Well, and I wouldn't say that without, if I wasn't feeding off of examples and real life calls that have come into our tech department. I mean, it happens more than you think, where they got one outdoor unit and they have the wrong indoor units, or they have the wrong wire to connect them, and even to the point where I've had contractors install the wrong wire and actually create damage to the equipment. So that's all I'm trying to say is, spend a little extra time, especially if you never put one in, and just make sure you have the right materials. So, and I'm not that kind of guy. The guy there's one specific example I have in my head where the guy hooked up a unit with the wrong wiring and it damaged some boards and stuff on the indoor units. I'm not going to beat him up over it. We got him what he needed. He got it fixed. The customer's happy. He's happy. That's not what my goal. My goal is for you guys to have a smooth installation of a GREE unit without any problems.
Right. No, that's a great point. Well,
all learn from mistakes, right?
Yeah, we definitely do.
The only way you're not going to make a mistake is if you're not working.
Right. Well, I tell you, as far as being prepared for it, I think the going and getting a 9-volt battery, for your micron gauge, or going to get a 9-volt battery for your static pressure.
Instead of taking it out of the smoke alarm?
Well, don't do that. Well, I mean, if it's your own smoke alarm, it's up to you. Don't do that at the customer's house. It's probably chirping anyway. But anyway, so yeah, there's a lot of great tools out there. I mean, I can tell you, if I was putting in one of these systems for the very first time, we do have a lot of videos on this on the GREE Comfort YouTube, as well as on our website. If you're wanting to do some research on it, that kind of thing. The reason why we upload the videos like we do is so that you can watch them whenever you want to watch them, whenever you have time to watch them. I do not recommend watching them while driving. But if you're just playing the audio or something, like maybe you can do that. But you better preparing yourself, that kind of thing. And you're not showing up and then you got a bunch of questions. You're trying to put stuff in, you get to a stopping point. You can't get past that stopping point. You're trying to make phone calls. You're calling, the distributor, you're calling whoever it is that you're trying to call, tech support, whatever, and then you're basically stuck on the job. And sometimes those questions are, they can be quick answers, really, they really can. But yeah, I will say, just to be a little bit biased here on the MultiPRO systems, if somebody gives you a 14.4 wire to go with it, because it comes with a line set, generally speaking, you're not using the 14.4 wire with a MultiPRO system. It's not how it is. Or if somebody gave you 14.4 with a FLEXX, you're not using 14.4 with your FLEXX, chances are. So don't go ahead and hook it up because the distributor gave it to you. They may not know either, that kind of thing. But but we do. We go through the videos, on the videos we go through everything that you need for those installations. We also have the manuals on there. If you like reading, you can do that. You can read the manuals. We've got quick start guides, quick reference guides, just about every tool that we think that would help people. I mean, really, the goal one day is the phones don't ring at all, right? Nobody ever has any questions anymore, and then we'll do something else.
Well, and I'm glad you brought up the quick start guides because that's huge, I think, because what we've done with those quick start guides for the ones that are listening that have never looked at one of our quick start guides, the whole idea behind the quick start guide is to have like a 20, 25 page document. A lot of it's pictures and stuff like that. So it's really short. But instead of you having to read the entire installation manual, it's going to give you all the key points to knowing how to properly install that unit. So we have them for the FLEXX. I think we're almost done with the one for MultiPRO. That's going up too. So we have them for the mini splits as well. I highly encourage, if you haven't looked at the quick start guides, to take a look at those.
Right. Gotcha. Okay. So now I appreciate you guys' input on that. Again, question mark icon to the right of the screen. If you are tired of me saying it, feel free to let us know by hitting the question mark to the right of the screen. Just little jokes here and there. All right. So now you get to vote whether or not you're going that Jesus should stay heated or chill out. That's at the question mark icon on the right of the screen. That's where you can go vote. So if he should stay heated, like people should be prepared for the job that they're about to do, then you say stay heated. Or if he should just chill out, just take a chill pill, whatever. Just go ahead and vote that way. During the meantime, as we're voting that, we're going to run a video about mounting a wall mount unit. All right, enjoy. Yes, that is where you vote, Suzanne. Uh, all right. Let's see if we got a tally here. How many stay heateds do we have? We got a lot of stay heated. Got a lot of stay heated. All right. So looks like we got 29 so far.
Wow.
On stay heated. We got one chill out. All right. That's the one cool person. All right. I'm just joking. Don't get mad at me. All right. Yeah. Looks like, let's see, the final. We're just going to go ahead and stop it right here. 29-1. All right.
Landslide.
Right. Yeah, it's a landslide. Yeah, I agree too. I agree. We should stay heated about that. I waste a lot of time on being unprepared. You do, we do, everybody does. But I thought about this during the break. But I actually recently heard of a distributor using DoorDash to be able. You can order parts sent to you at the job site from DoorDash, from the distributor, from the parts house. What do you guys think about that?
I think it's great as long as you get a Subway sandwich too on the way.
Well, I guess you could probably add to your order, right?
Yeah.
I think it's great too. I mean, I can tell you that, you know, I couldn't afford to leave the job, and I definitely didn't want the guy who was helping me driving my truck. So there's, there's definitely, definitely times where that could have been really, really beneficial, really, really cool. Um,
There's a couple of distributors that do that, but you have to meet X amount of ordered whatever merchandise you order. So, like for instance, minimum 500, they'll come out wherever you're at. Not
right.
sure if
Yeah.
it's
As
all of
far
them,
as
but some of them.
no, I think using the let's say the delivery app. Maybe there's also Uber Eats or whatever. You know, I don't know if anybody else has got
Yeah.
some stuff like that. But from what I understand, there's not a minimum on that. As far as them driving the truck to you and all that, yeah, equipment orders, that kind of thing, then yeah, they typically do have a minimum. But anyway, I thought that was a you know, it's one of those. It was almost like an obvious idea, you know, like it's like, man, why didn't I think of that? You know, it could have just been I could have been the guy who came up with that idea, you know. But anyway, I thought it was a really good idea. I don't know what you guys think, but you know, if you got comments on that, feel free to drop them in there. All right.
I think it's a brilliant idea. Oh, I can't, you know, makes sense to me.
Yeah, it's true.
Right.
I don't think it probably works as well in really rural areas, but you know,
Well, yeah. I mean, you never know. You never know. Hey, they can meet you halfway or something. Hey, who knows? You know,
there you
however
go.
you set it up. But then you're racing someone who drives for a living. So good luck with that. You know. But okay. Next, we're gonna go to our YouTube comments. Our channel on YouTube is GREE Comfort. All right. So let's take a look at these comments. FLEXX 3-ton with ultra heat for use in a ducted system so that I can get heat down to minus 35 degrees Fahrenheit. That's something in Celsius. I don't know what it is. And we installed the 3-ton FLEXX with a 5 kilowatt heat strip when the temperatures drop down below the submittal lowest temperature. Well, I gotta move a warning message out of my way here. All right. When it drops below the submittal lowest temperature, is the heat strip the only thing providing heat? Also, I want to verify if the FLEXX is providing heat at the same time as the 5 kilowatt heat strip with a dual fuel thermostat. Okay, first off, on heating mode on the lowest temperature, we do not have a built-in lockout at the lowest temperature. It will continue to provide heat as the last few years have shown. It will continue to provide heat pump heating at those temperatures. Okay. So yes, you'll still continue to get heat out of that heat pump. And yes, you will, if you've got a heat pump thermostat, you've got 5 kilowatt heat strip, and you know, and W2 is wired, you will get the electric heat to come on at the same time as your heat pump. So it will supplement. It won't be the only thing running. It will supplement the heating that's being provided by the heat pump itself.
And we have extended ratings that will tell you how much heat down to minus 22. Don't
correct.
go below that.
Right.
Once you get below 22, you're beyond the rating on the unit. Doesn't like James said, it'll still produce heat. We just can't tell you how much.
Right. Yeah.
So you may need to, depending on your load, 5K kW may not be enough. You may need to go to a higher heat strip if you're getting down to those kind of temperatures.
Right. Now, I can't speak for every manufacturer because I have dealt with I've worked for other manufacturers as well. And there were some units that had built-in, you know, cold lockouts. You know, once it dropped below a certain temperature, it says, okay, we're not going to run anymore. Some of those were, you know, in the 20s, which isn't great. Some of those have been like -4, you know, that kind of thing. But so the submittal data, you know, or the rated operating temperature, it's a rated operating temperature. That means it's been put in a HRI certified lab, for example, and then they drop that temperature down with that unit running, and then can show you what the capacity data is. That's what our extended ratings tables show, which are available on GreeComfort.com under extended rating tables for that product. But yeah, so we can show you to -22 on most of these products. I can promise you we've definitely seen those operate at significantly lower temperatures than -22. I think we'd have a hard time selling heat pumps like we do, as successfully as we do in North and South Dakota, for example. Shout out to the folks there that support our equipment there. They've seen temperatures down in like minus 40 before. Again, what that is in Celsius, I have no idea. It's just really, really cold. You know, uh, God love you. I wouldn't do that. I'm just saying, I'm just going to stay down here. But yeah, it'll still perform. Now, whether or not that's going to be able to meet the set point that you're looking for at 5 kilowatts, there's going to be quite a bit of calculations that are going to have to be done on that. You may be able to interpolate some of the data to see what it might do. Like if you follow the curve down past minus 22, and if that heating performance plus the added 5,000 watts worth of electric heat that you're adding, if that was enough to meet your set point at that temperature, then it should have no problem keeping up.
A lot of the thermostats too, it depends on how you set up the thermostat, because you can actually set up the thermostat depending on the manufacturer of the thermostat. But you can set up the thermostat to not allow the auxiliary heat to work until it hits a certain whatever program temperature you put in there.
Mm-hmm. Right.
You can also set up timers on them to where, sometimes, I did this on my last home. I had a gas furnace, but it was a 2-stage furnace, but I was able to put a timer on the second stage. So even if it called for second stage, it had to reach that timer amount before that second stage was allowed to fire. Same thing here. You could have a timer in there that says, okay, 15 minutes. I've got to have a call for that auxiliary heat for at least 15 minutes before we bring that electric heat on. And the reason why I encourage that is because if you have a consumer that turns the temperature down at night and then goes and cranks that thing back up in the morning, for example, they're bringing on that electric heat unless you put some kind of timer in it to keep that from happening. So,
right.
Then they're calling you saying, hey, but you told me this heat pump was so much more efficient and my electric bill is too high. So you got to keep all of that stuff into consideration, when you're, going to this inverter driven unit, which is going to be significantly cheaper to run than running straight strip heat. But you also, if you're putting strip heat in there, you got to make sure you're setting that up so that we're not bringing it on all the time. Because you don't, with that FLEXX system, chances are at 0, -4, stuff like that, you ain't going to need that to come on. That heat pump will do it.
Right.
So,
well, what kind
more
of
to think about.
Yeah, absolutely. I mean, what floors me a little bit is, let's say 16 years ago, when I was having these conversations, we were talking about whether or not these heat pumps would be able to perform in the teens. And I had people insist that they absolutely had to have a dual fuel system, and they lived like in the Southeast. They absolutely had to have dual fuel because heat pumps just can't keep up, that kind of thing. And looking at the temperatures that we talk about now, looking at the areas that we're selling heat pumps in now, is so much different. I mean, in my lifetime, which I like to think is relatively short, but it's not. It's quite a long time. But in my lifetime, we've gone from, heat pumps really don't work outside of Florida, given a particular brand name at the time, right? They don't really work outside of Florida to now, they're pushing so far up north that, which you were only able to heat with fire for a very long time, and now that's what we're talking about. Like, how do we get away with only having a 5 kilowatt heat strip, right? Instead of doing like a 10 or a 15 or something like that.
You're not wrong, because when I was in the field, which has been 14 years plus since I've been in the field, but I did a lot of heat pumps, and those heat pumps in that era, they really started dropping capacity below 15 degrees.
Yeah. Well, as a matter of fact, we ran the numbers on that when we were comparing it to like a MultiPRO. And, even your high dollar inverter driven systems, I'm trying not to name brands or anything. Even your high dollar inverter driven systems, even some of your favorites, all the way down to your more economical units. If you take a 4-ton, for example, and you go look at their extended capacity data, you'll see what you're getting. You'll see exactly why that auxiliary heat is kicking on when it does. And it's because you could take a 4-ton and it's 4 tons of heating at 47 degrees. It's 3 tons of heating at 36. So, you're losing 25% capacity in a matter of 9 degrees, in much of the equipment that's out there right now. So yes, heat pumps in general can save you money, particularly when it's relatively mild. But when you're starting to talk about, in the single digits and all that, you've lost so much of the capacity out of a standard heat pump that you've basically got an electric furnace at that point. There's an argument you made on, capacities and COPs and stuff like that at that point. But most people, once you factor in defrost as well, they'll just go, oh, you might as well just turn off the heat pump. But that's something that we've had to battle a little bit on the thought processes, especially since we've got units that now can operate with a dual fuel system, is, just automatically switching the gas at a certain temperature. There's probably some more math to do if you're looking at trying to save money, COPs versus your energy costs, like electric energy costs versus your gas energy costs. What are you getting per therm out of, like BTUs per therm out of gas versus what you're getting out of a high performance cold climate heat pump? It's, that difference is getting narrower and narrower every day.
Especially if you're on propane.
Yes,
so you're
especially
talking
if you're
propane
on
versus natural gas. It depends on which fuel you're talking about. And
right, or you can also
propane,
throw in things like butane or fuel or whatever, and those things can be fairly expensive as well.
and the market for propane can be very volatile. I've seen that price go, from normal to just get a cold winter, and the price of propane just shoots through the roof.
Right. Well, it's made from the same stuff gasoline's made from. So
Right. So if you're on a pre-buy, you're going to be paying a bunch of money for some propane.
Right.
So
yeah.
Yeah.
But there's definitely some conversions to be done. I mean, I think if I were living in a place that got to minus 35, just a recommendation from me. I'm not saying that there's anything wrong with trying to heat with that. But minus 35, I'd probably have two sources of heat at minus 35. I mean, that's not me being chilly overnight. That's significantly colder than chilly. But just throwing it out there.
Right.
If you can have the timers and stuff like Greg was talking about set up, or if you did a temperature differential setup as well as the timer, then you could use a larger heat kit and just keep that heat kit off. You keep that heat kit
until
off
it's really needed. Yeah, exactly right.
until it's really needed, and then you've got enough heat. Let's say with a 10 kilowatt or 15 kilowatt, depending on the heat loss calculation, you got enough electric heat that if all else failed, some kind of once in a lifetime winter storm comes through or something like that, you're still nice and warm. Speaking of once in a lifetime winter storm, me and Jesus went through one for Texas, which consists of a little bit of snow and some ice and 0 degrees. And that was enough to just, that
They shut down the whole state practically.
Yeah, that's Texas, by the way. We're not really accustomed to all that.
No, not at all.
So the second set of questions comes from video lightning round, 8 common questions on GREE's FLEXX system. All right. One person says or asks, what is the minimum maximum compressor speeds or the min-max wattage draws in cooling? All right. Well, one of the places that you can find that is our extended ratings tables. You can see, the power consumption or the current or the wattage at various temperatures, both outside and in. You can take a look at those. You can also look at, for example, the minimum circuit ampacity. You kind of base it on that. On the submittal, I was in the process of looking through to see if the rated power input was also on there. I don't. Yeah, I got rated current, like an MCA 24, for example. You can do some math based on that 24 there. You can kind of go from there. But on the max output, like if you were looking at cooling, like the second question on that was like, he says, I would like to know this too. I have a 2 to 3 ton set as a 2-ton mode. The condenser draws 15 to 1800 watts, depending on how hot it is. And they said, I thought it would go lower, like 1,000 watts. Okay, well, let's take a look at the extended ratings on that. And if you're looking at maintaining like a 70 degree temperature inside, you can draw up to 3,300 watts when it's 129 degrees outside. So you can get up to a very substantial amount. Of course, at that point, you're also providing 20,000 BTUs out of that 2-ton unit at 129 degrees, which is what you'll find the FLEXX system actually significantly outperforms most units out there, not just in heating but also in cooling. it being rated to 129 and still providing 20,000 BTUs at that temperature. But under normal circumstances, let's say at 95, you're looking at about 1850 is what is indicated on there. 95 degrees, 7 degrees inside, 59-degree wet bulb, 1,850 watts or 1.85 kilowatts. That's just, that's what it's going to do when it's running full out. That's not what it's doing during its ramp up period. If you want something that might draw significantly less current during the same amount of time, you can take a look at our MultiPRO systems as a 1-to-1. All the features and benefits that you wanted out of the FLEXX you get with the MultiPRO. You know, it's our top tier system. It can draw significantly less energy. It does have higher efficiency ratings in general than the FLEXX, and offers a variable speed indoor unit as well. And you can add, you know, multiple indoor units.
And let's not forget what I said earlier about the whole idea behind inverter-driven systems is to maintain the load. So once you get that load under control, that's where we don't want these big offsets in temperature, especially when it's hot outside. You need to set it, leave it alone, because we want that heat pump to try to maintain that temperature at those lower hertz levels, because that's where your efficiency is at.
Right. Right.
Set it and forget it.
Somebody was kind enough to let me know that minus 40 Celsius is the same as minus 40 Fahrenheit. So thank you. Both extremely cold.
Definitely not a climate I would want to live in.
No, but hey, if you've ever gone to those places in the summer, it's absolutely gorgeous.
Oh, I'll go in the summer.
Yeah,
I ain't
absolutely
staying there
gorgeous.
for the winter.
Yeah, I know. If I get a request for training, it's always, you know, Bismarck in February. No offense to Bismarck, it's just very cold. And it looks like I got a lot of insulation, but apparently it doesn't work. So, okay. I'll tell you what, we're going to take one more look at the question and answer here. So this is basically a last call for questions.
I like the participation because I like, you know, we'll talk about whatever you want. You just got to throw the question up for us and
Let us know.
you get our minds stirred up.
All right. So there was a follow-up question to the unoccupied, occupied. I guess just a little bit more detail. When the thermostat goes in unoccupied mode, it increases the set point. It automatically increases the temperature that you would like it to be. So you're not supposed to be there, so you shouldn't really care. And then if you've got a schedule for that and you knew when you were going to be there, then you might set occupied for a certain time, and then it would go to occupied mode, which would then decrease the set point back to what you consider to be comfortable.
But I think that unoccupied mode, if it's adjustable, depending on what control he's talking about, I would make sure that the unoccupied temperature is not a whole lot different than the occupied temperature. So we don't want it to just increase the temperature significantly in there in cooling mode or vice versa in heating mode.
Right. Right. No, I definitely agree. Particularly in heating mode, like what we were talking about earlier. You know, having it go to occupied, having that set point go up 10 degrees or whatever you thought you were saving money on. If you bring on electric heat, if you've got it, if you bring on a heat kit, you're paying. You're paying for whatever you saved in the meantime, you're making up for in that, however long it takes you to get there.
And if they do that, rather than do that, they could just stand there at the window and open up and start throwing out $100 bills, and I'll slide by and grab them.
Well, I mean, I don't know, $100 bills. Yeah, it might be a few bucks, whatever it is, but you're definitely not getting the efficiency that you wanted out of it in the first place.
Oh, you've never watched a meter spin 15 kW running?
Mine's like
a flying saucer.
Yeah, say slow down.
I got a digital meter. I don't have one that spins anymore, Greg. I think that's
Oh, showing my age again, ain't I?
Showing my age too. I know what it is at least. I always thought they should put fan blades on it, to help you stay cool in the summer. I mean, if it's going to be spinning, might as well cool off something.
Just to add on the unoccupied and occupied, pretty much just going back to making sure that those controls are set, the correct way. So pretty much setting the correct parameters as to what you want for that given space. Because, you got to remember each space is going to be different, depending on what cooling that you need, whenever it's occupied and unoccupied. So just making sure that those are correct the right way, or set the right way. I mean, sorry. Just to make sure.
Right. Another question is, how do I become a GREE Select dealer so that I can offer, among many other benefits, a 10-year warranty on mini splits, FLEXX, and MultiPRO? And what you'll do is you'll go to greecomfort.com, and you'll see the contractors tab above. You highlight that tab, and then you click it on your phone, and then you go to become a GREE Select dealer today. And it goes through and gives you some descriptions. It's got a wonderful video with our own Tatiana Forrest in there, telling you everything you need to know about the GREE Select dealer program. It lists out the advantages of it, the requirements of it. It also lets you you get some free stuff comes along with it, marketing literature, like a nice hat, like the one I have right here. I mean, obviously, I'm not a GREE Select dealer, but I do know a person, so I got a hat. But again, that's greecomfort.com. Under Contractors tab, you go to Become a GREE Select dealer today. Everybody likes a 10-year warranty, so that's a great way to get it. Let's see, let me get back to my questions. All right. I'm having to wade through all of the heated comments. there's a lot of them. All right. Well, I believe that's all we have for today. I really appreciate you guys' time. I know that everyone's busy, even though it's beginning to cool off a little bit. I know everyone's busy. We are too. I appreciate that. I appreciate your input. So from Greg and Jesus and me, we'd like to thank you, and see us next time for our next episode, which is always at the beginning of the month, every month. So we'll see you in November. And remember, at GREE, we're by your side.
Hey, thanks for watching Talking Comfort Live with GREE HVAC. Make sure to keep a lookout for an invite to our next show, or subscribe to our GREE Comfort YouTube channel to make sure you get notified anytime we release new content.